Hello and welcome to the Disruptive Innovation Festival, the online festival ideas that ask the question, what if we could redesign everything? My name is Emily and I'll be your host for this session, which is all about biomimicry design tooling and the role of biomimicry within education. I'm joined today by Laura. Laura is a senior lecturer at The Hague at University of Applied Sciences and a PhD candidate at TU Delft and Uni of Leiden. She'll be talking to us for about the next half an hour and showing us a little slide presentation as well. Don't forget this session is interactive. We really encourage you to post your comments and questions to Laura in the box below this video. And you can also get interactive on Twitter by using the hashtag ThinkDiff. So without further ado, I'll pass you over to Laura to get started on this session. Thank you, Laura.
Hi everybody. I'm Laura Stevens. I come from America, but I have lived in the Netherlands for 35 years. And I am a teacher at The Hague University, as we said. I will turn on my presentation and then, let's see, share my screen first. Let's see, that was over here. Here we go. So, my presentation today is about biomimicry design tooling and how this fits in the circular economy of education. And as I have already been introduced, I am a PhD candidate. And I'd like to find out from other teachers, or perhaps we have even students joining us today, what are the difficulties or what are the easy things about learning biomimicry in the classroom? I work at The Hague. I am also doing a Master's of Science at Arizona State University. So that is where I'm learning biomimicry from the experts. And I'd like to look at these, look at the classrooms, learn how to really integrate biomimicry into the classroom at industrial design engineering and find out what the decisive learning variables are that will have the highest effectiveness of learning biomimicry. And what I mean by this is what is easy and what is difficult. What hurdles do students have when they come into the classroom, when they have a design jam on biomimicry, and how do they deal with these? When do they start to connect? Or maybe more importantly right now is to find out when do they disconnect. So first of all, the challenge that you give them in the classroom, I think it has to be real and it needs to really matter. This is one of the big five of education at the University of Leiden and Naturalis. And the 5 points are that it should be, it should bring about a sense of wonder. It should be real. The challenge should be relevant. It should be inquisitive and also scientific and scientifically sound. So, are these challenges sound? Now, the last challenge, and this one is about collecting microplastic microparticles from the ocean, as we've seen. Possibly some of you have seen in Delft, they designed the ocean cleanup. So I gave my students the same challenge to collect those small particles of plastic that are in the seas. This is one of the major problems we're going to be coming across more and more, since there's still so many plastics in the world. So the students looked at all kinds of creatures, like the mucus from the parrotfish and the burrowing sea cucumber, and how these animals, how these organisms, how their mechanisms work, what their strategies are, and how could you use this in your design. So one of my questions is, what teaching instruments do you bring to your classroom, or do your teachers bring to the classroom? And are these instruments the things that you need, or are you missing something? Do you bring in biological champions to bring in this sense of wonder? Have the students been, or have you as a student asked about the biological knowledge? And have you done scientific research? I have to thank Jane Toner from Australia for these examples. She gave me a set before my last workshop. And it was a really great help to have some in-depth research about a lot of different organisms that deal with water challenges. So how does the mangrove deal with water challenges? How does it filter water? How does it gather its nutrients? And the thorny desert lizard, how does it get the water that condenses on its body to its mouth? How do fairy rings bring the water to where it's needed on the edges of the circle? So these are all things that we've been looking at in the classroom and have helped me bring this sense of wonder and the biological knowledge and the research into the classroom. Another question I have is about the interdiscipline teams. Do you have a classroom full of designers from industrial design or architects or other built environment specialists? Or is it just one group, or is it an interdiscipline team? Now here's an example of a climate student on the right, an ICT faculty member on the left, and a business administration faculty member in the middle. And they got together and they came up with solutions to solve both the heat challenge and the intensive rain challenge, falling onto the impervious cover, the rooftops and the asphalt and the ground in the city of The Hague. Because the city of The Hague also has these problems that you come across in Phoenix, for example, also has the urban heat island challenges, and The Hague even has them too. It's when you feel that there's more heat. And let's see, in 2006, even 1,000 people died of the problem of extreme 2 heat waves that we had here in the Netherlands, and became in the top 5 of countries that had a death. So this is something that we see now just starting to emerge, but these challenges are going to be coming more and more in the years to come. In 10 years, maybe it's 10 times a year. Maybe it's 10 times a month. I don't know yet, but maybe our students, if they can learn about these things now, they can come up with solutions to these challenges. And also in a fun way. Learn about them fun now. Well, we're not, and it's going to become urgent, but the time is now to really dive into it. So that's one of my questions. Are your teams interdisciplined? I think they should be. And for your classroom, how much time do you have? Do you do an hour workshop, just a teaser, or 2 hours or 3 hours? Or do you have a day to work on the workshop with your students or with your teacher, depending on which side you're on? Or is it an entire program or a classroom or a module or semester? I went to Vancouver in the summer and learned from how they did it in Denmark. They had a 3-week period that they really worked on the same type of challenge that I've been working on. Except they were working on it for 3 weeks, so they could really dive into it and deeply look at the mechanisms and the strategies that nature has to offer. And at the same time, I'm trying to fit these into 2 to 3 hour workshops. So I can imagine for mine workshops would be at this moment, but still quite just the teaser to get the interest started. While in Denmark, they would be much more in depth. Also, what kind of student-teacher interaction is there? Are there one-on-one assignments, or are they assignments in groups? This is an example of another workshop I gave. You can see here that they looked at the same water problem, and it was quite funny how they came up with a sculpture garden that was inspired by the sponge, and how if the rain came down really, really hard, then each city in Leiden, you would have the T-Rex, because we have a T-Rex here now. And in The Hague, you have the Haagse Harry, which is a figure of The Hague. And each of these would swell up here like this cat, which kind of reminds me of the dog at the Guggenheim Museum in Bilbao. But these would swell up with when it rained too much. That's to absorb the amount of water and hold on to it temporarily before it flows into the ground. But that's getting off the point. So are your workshops one-on-one assignments, or do you work in workshops with groups of students? Another question I have is, what is the level of training, either of you as a teacher or of your teachers? Have they done a weekend workshop, or have they been able to go to a week-long immersion workshop and learn the different strategies and the principles that biomimicry has to offer? And how about the level of scaffolding of the course? Is this something that's set up completely ahead of time, like a long online course? Or is it a quick workshop where you have a few sheets? What kind of background is already ready when you go into the course? So I know there's a lot of questions, but maybe you guys are writing down your questions and you can ask me or answer some things at the end. Okay, I put this slide in here to show lots of different directions that I've gone with in the classroom in biomimicry. So either looking at the organisms, looking at the biological strategies, and how you could translate these to abstracted design principles to see that what this is about is the biologist will talk about the biology, how the sponge works, for example, sucking in water through the openings here where it goes through these flagella that are pumping the water through. And what is interesting about the sponge is that it will filter almost 100% of the bacteria out. So if you look at this in a more engineering way, maybe this is something that could work in the health field, filtering out the bacteria. So all these organisms is how you would translate the biology into the engineering. So what we're looking at right now are the analogies from nature. And how do you translate? How can students internalize this biology knowledge, the knowledge from life, from nature outside, into actual engineering principles? This is something that I really have been looking at more carefully since I became a student at Arizona State University. And this is what they also teach us there, is to look at nature in the different ways and try to figure out the mechanism that is making this function that you're looking for work. And I say function, for example, a shade tree how would it diffuse light? So how can it be cooler under the shade tree? And with the cactus, that you've got the ribs here and the sun will shine on one side but not on the other, for example. So these are all different examples of abstracted design principles and diagrams, that is, the drawings of the diagrams, and then the description of what the organism is actually doing is the abstracted design principle. So it'd be like, I think it's essential. This is what I'm finding out more and more. This is essential to my research, is to find out more about how students can internalize these analogies, the biological analogies, and not simply to just copy form, but also to copy and be able to mimic the structures and the patterns and the systems that are there, because you can't just do one thing. It should also be a multifunctional thing. Here down at the right-hand corner, I looked at different lenses to look for solutions for different challenges. And the first one, you could see the nanoplastic particles. How do you clean up the nanoplastic particles? And the second would be for the urban heat islands, for example. And the third for how could we avoid traffic jams? So looking at through a different lens to see how nature avoids these traffic jams. And the local lens, I didn't do a very good job on that, but I put it in anyways to also show I also make mistakes because I've lived all over the world, so I took things from different places. But the idea of the local lens is to look at one specific place and look at the operating conditions in that area. Well, maybe if you have any questions about this one, we can come back to it, but because I know it is a lot and I don't want you to disconnect, and this is one of the things I've been talking about. So I will move on and show you just a quick example of another solution that students came up with for filtering out the plastic particles, and another solution where they were also filtering out the plastic particles and just gathering together the organisms and how they work, getting inspired from the organisms themselves. And then these are the last two pictures that I wanted to share with you. Is how can you reconnect with nature? Is this part of your classroom too? Is this one of the moments that worked, or is this something you think this might be useful? It's going to nature. Here we went to Hortus Botanicus in Leiden and looked at the different forms and functions and structures and patterns within nature to see how these could be useful. Why is that cactus twisted? What about the lotus leaf with its nanostructure on top? So that structure keeps the lotus leaf clean, which is really, really important for photosynthesis. So how can we mimic that on the side of buildings? It's already done. And so is this something that you've looked at in your classroom? So my goal is to find these relationships between the biomimicry teaching methods and learning biomimicry so that we can introduce the correct procedures, what is correct, to the most effective procedures into any curriculum, actually, because when I interviewed Dana Baumeister a month and a half ago, she said, well, with the biomimicry education, it already fits, about 80% of it fits into other curricula. So, if you have had some of the training, or if you're in a totally different field and you're not quite sure how it fits into your life or into your work, it's not really something that needs to be worried about, because 80% fits pretty much any challenge and any field that we're working into. And finally, I'd like to come up with a hypothesis or a theory about which teaching variables correlate positively, so which were effective for students, and which correlate negatively, so that I can make a proposal to introduce them into new curricula. And if that is industrial design engineering, or for the built environment to solve the urban heat islands or the water problems that we're having more and more, that's fine. But I have seen how well the potential is for biomimicry, and so I'm really curious as to see if anybody has any questions. So what I need to do is now to stop my sharing and see if I see there are a few questions here. Can you see me again?
Not yet.
Not yet. Okay.
Soon, I'm sure.
Let me see. No, you should be able to see me now, I think.
Maybe if you go back onto your camera.
Turn camera on.
Your screen on the left-hand side.
Okay.
There we go.
Okay, good. Sorry, guys. Sorry.
No problem at all. It's absolutely fine. That was a great session. Thank you so much for sharing that with us, Laura. Really engaging presentation, and some of the drawings from your students are fantastic.
Yeah.
So we've had some questions in already. So the first question I'd like to ask is from Eliza, which has actually come through on the comments section below. And don't forget, if you have questions that you're still eager to ask, please do post it in the comments box below this video, or use the hashtag ThinkDiff. So this question from Eliza says, hi Laura, is there a question that we can ask ourselves when looking at the world around us to adopt biomimetic thinking?
Ooh, is there a question that you can ask yourself? Yes, I think there is. The question would be, what is it I'm seeing? What is it I'm seeing? Take a closer look outside. Go outside. You have to go outside. Go outside and even take a little magnifying glass with you and look at what is there. Look at the, ask yourself, what patterns do I see? I can give you an example. When I go outside into my garden, the hazelnut tree and a geranium, a wild geranium growing in the wall, they all have this kind of fuzz on it. Why in the world do these organisms have fuzz on them? So in the operating conditions I live here in the Netherlands, there is a reason why these things are. And then you can go and ask a biologist, why? So keep asking why.
Thank you, Laura. Cool, so we've got another question in from Twitter this time. It's a bit of an open-ended question, but it's quite an intriguing one from Jerona. She asks, nature doesn't produce waste, does she?
No, I don't think so. There are people that disagree with me, but I don't think nature produces waste. No, I think it produces resources. And one man's junk is another man's treasure. So look at the dung beetle. It picks it up and does something with it. And actually, waste from the GNU or some animals in Africa. This could be a resource that kind of ants bring in around their tunnels, and all kinds of grass grow because they bring that all back to their mounds. So no, there's no waste. The man-made waste still eventually will turn back into oil. So if we can learn how to keep it in this circular economy, we will be much better off, because then we'll make use of all these resources that we have an abundance of right now. They're just so dispersed that they're difficult to see.
Thank you, Laura. Thank you for going into a bit more detail there. That was some interesting ways of expanding on that. So thank you. So we've got another question from Chris. Chris asks, does growing a material use less energy than other methods of material formation?
I'm not sure if I understand the question. Does growing a material, could you repeat the question again?
Yeah, of course. Does growing a material use less energy than other methods of materials formation?
Okay. Growing a material. You know, I don't know the answer to the question, okay. But I can imagine, for example, they're making lamp covers out of mycelium, the roots from mushrooms. So all you have to do is make the mold, and then the roots grow into that form themselves. And it uses less energy, for mechanical energy, to use that. But it comes from the energy that it comes from the organism itself. It's all about using the readily available and local resources, materials and energy that are close by.
Yeah, okay, interesting. And it's interesting you brought that up, actually, the whole you using mushrooms. We've got a session coming up next week, actually, with the founder of Mycelio, with Rick Plouts, which is in week 3, which you can find out more about on the DIF site, which goes into a little bit more detail about that. So it's interesting that you brought that up just then, actually, because that tied in quite nicely there. Right, we'll move into another question then. So we've got a question, quite a long question, actually, but here, I'll give it a go.
Okay.
So this is from Viviana. She says, hello, Laura. I'm a graphic design student, and I'm very interested in nature, animals, flowers, plants, and the environment. For many of my projects, that's where my inspiration comes from. Recently, I did a branding project where the logo inspiration came from the structure and pattern of leaves and trees. I was wondering if you can give any advice for using biomimicry in the graphic design field, and how would you go about finding the process from finding something in nature that you think to link to? Oh, well, you're quite prepped here with it.
Well, Viviana, thank you very much for that question. Because one of the courses that they teach at Arizona State University is called Eyesights. And that's all about looking at nature and seeing the patterns and the structures. And this may be something that you already quite know about, but I can show this example. Ooh, I don't know if you can see that, but it's about a leaf, and the structures and the patterns are in there. So look very closely to the patterns that you can see in nature outside. And plants are pretty easy to look at because they stand still. If you look at animals, they tend to move around a lot, but plants are pretty easy. But also things like the Fibonacci, or the golden rule, that if you look at sunflowers and other flowers, for example, you can see the patterns of the spirals. For example, there'll be 13 going in one direction and 21 going in the other direction. And if you stick to those patterns, or at least do some examples with those patterns, then that might inspire you more. I mean, I'm sure you know the nautilus and you know a lot of these other patterns, but just keep practicing those type of patterns. And I think things tend to fit better, because I had no idea that there were so many examples in nature of these same patterns. The pine cone, the sunflower, the yeah, it's called some kind of thistle. Everywhere, it's just everywhere. So, well, there's another big long question coming out.
That was a great answer. Really interesting, and you were very well prepared then, which is great.
Yeah.
So another question from MWP. This question asks, disruptions to ecosystems can be enriching, such as a storm that opens up areas of forest floor, which can lead to increases in biodiversity. Can you think of an equivalent for biomimicry teaching? Are there ways in which you deliberately disrupt your students' design processes?
Oh, okay. What a great question, because this is actually one of the things that Janine Benyus and Dana Baumeister talk about, is that when you get a disruption in the jungle, there can be an opening, and then in this darker jungle, all of a sudden the light shines through, and that gives opportunity for new growth. So how do I have that in the classroom? I think maybe it's my American enthusiasm and bubbling in there with all kinds of information, with organisms, with abstracted design principles, with nature technology systems, doing audits with life principles. That's pretty disruptive. And then I see the eyes start to glaze over of students because they're getting a flood of information. And then I know I've kind of disrupted them. But also it blows them away, but it also plants the seeds that they can start the next time they hear about low energy processes, or not using toxic chemicals, and so using life-friendly chemistry and any of the other life principles in biomimicry. They will remember it. They'll say, "Oh yeah, that crazy class Laura had," you know. So I think that's might be one of the things that fits with me. Disrupting.
Yeah, I'm sure you've had some crazy classes. That was another interesting answer. Thank you, Laura. So we've had another fairly long question in, but it's a great one, so I'm just going to go for it. Okay. So this one's from Sarah in the comments section. She says, "Hi, Laura. Thank you very much for such a great presentation. My question is based on what you have observed in the classroom. How do you think this learning environment compares to that of an industrial learning environment? I am creating an introduction to biomimicry course for my company and was wondering, would you suggest focusing on a certain aspect of the biomimicry process to get industry folks intrigued and inspired? Problem definition or design abstraction, etc. Or are there tools you think would be best for industry folks to get introduced to as an introduction to biomimicry?"
Well, that's a lot of questions. You know, you can find me on LinkedIn and on Facebook and stuff, and ask each one of these questions again, and I'll be happy to go into that conversation with you. But I'll try to see if I can give a little bit of help right now. If you have an industrial challenge, what is that challenge? Try to define it. You would do this in any kind of design process. Try to find out exactly what it is, what you want to happen, or what not what you want to happen, what you want it to do, and then start looking for organisms in nature that do that. So it's exactly the same design process, the same design thinking process. You have the scoping of the challenge, then you have the discovering of the challenge, what kind of organisms would fit that scope thing to do. And then you have the creating process. We do that in design too, all the iterations, lots and lots of ideas. And then the evaluating, where you also use life's principles again to evaluate how good have I done it. So if you go through those design thinking, biomimicry design thinking principles, then you'll be there.
Great answer. And yeah, as Laura says, I know she's really keen to get as many questions in as possible, but we only have a certain amount of time. So please do contact her on LinkedIn or keep the discussion going in the box below this video. Laura can get online and she'll be able to answer your questions and keep in contact. She's currently working on her PhD project, so I know that these will be super useful to her. So do keep them coming in even after the session is finished. So I think we've got time for one more question. This one's from Leah. She says, hello, Laura. I'm a public health professional and I work in chronic disease prevention.
Wow.
I'm quite interested in built environment and how we can design our communities in a way to keep humans healthy. How do you think we can use design cities, towns using biomimicry to prevent diseases?
Oh, you have to contact me. This is one thing. I've just became one of the experts for the province of South Holland on exactly this subject, because they want South Holland to be the province, the most healthiest province in 2040, and looking with a lot of other experts in different fields on how we can make this happen. So one of the things is about being happy, and also with the built environment. How does that built environment make you happy? Or there's just so many ways of looking at it. I mean, do you have space there? We look at a lot of different built environment challenges where I work, and I do these workshops mostly on the built environment solutions space, because I think it's more tangible to the research group I'm working with at the moment. And yeah, I think it'd be better to just contact each other, and or you contact me, and I'll try to help you from there, because there's so many opportunities. It's too short of a time to answer that in one minute.
No, that's fine, Laura, and completely understandable. These questions are fantastic, and I'm sure we could deep dive into them a lot more. So please do contact Laura, as I say, in the comments box below this video, or through her LinkedIn profile. So that was a fantastic session. I think we'll leave it on that for now before we get bombarded. But I really enjoyed that session on the role of biomimicry education. Thank you, Laura, and thank you to our audience for so many fantastic questions and for tuning in. So a next session coming up at 3 p.m. We've got collective awareness, stimulating our economy with Doing Pharma. It's going to be a really great session in our live studio, so make sure you tune in for that. We are coming towards the end of week 1, but don't forget that we've got 2 more jam-packed weeks full of sessions. So please do visit thinkdif.co to explore our schedule and get involved. Thank you again, Laura, and thank you, online audience, and we'll see you again soon.
Bye.